Assalamualaikum students, I am Ahsan Abdullah Patel. Today we will discuss circle properties of O-level mathematics. So some basic properties I have to discuss. First of all, I would like to tell you something about what is basically circle. A circle has radius. Basically radius is the distance from center to boundary. It always remains the same at any point on the boundary. Diameter is basically the longest chord passing through the center. So basically two opposite ends when we join passing through the center, the line is called diameter. Chord means joining any 2 points of the circle, and tangent basically passes through only single point of the circle, not by 2 points. So the first property is basically about the chord. Perpendicular bisector of chord, we are talking about perpendicular bisector of chord. We are talking about perpendicular from center to chord. We are talking about bisector from center to chord. Basically perpendicular bisector is a collective property of these two properties. So the first property, I would say rather, perpendicular from center to chord. Whenever we make a perpendicular means 90 degree. Whenever we make a perpendicular from the center to the chord, it will always bisect the chord, that is dividing into two equal parts. So AP will always be equal to PB. The second thing is that bisector from center to chord. Whenever we join the midpoint of the chord, that is we are taking P is equals to midpoint of AB. So if we join center with the midpoint, it will always be a perpendicular. So collectively we can say the perpendicular bisector of chord. This line OP is basically the perpendicular bisector of chord. So these two triangles will always be congruent because this line, both are radius. This angle is 90 and this angle is also 90, and this line is basically the common line, the common side. Therefore by side angle side, or rather RHS, these two triangles are always congruent. The second property, that tangent, I have told you before that what is basically tangent, passing through a single point. Tangent is always perpendicular to the radius at touching point. Tangent will always be perpendicular, that is 90 degree. Tangent is always perpendicular to the radius. Equal chords are equidistant from center. So basically this is the center, this is a chord AB, this is also a chord CD. So there are two properties which are vice versa. Equal chords are equidistant from center. If these two chords are equal, then they must be equidistant. Equidistant means that these two distances from the center will be the same, or by vice versa, equidistant chords from center are equal if these two chords are at equal distance from the center. Then these two chords must be equal, that is AB, the length of AB is equals to the length of CD. Angles formed in a semicircle will always be a right angle, that is 90 degree. So basically if this is a diameter always cuts a circle into two halves. So basically this is a semicircle and this is also a semicircle. When a triangle is formed by a semicircle, inside a semicircle a triangle is formed with the diameter, it will always be a 90 degree, that is a right angle triangle. Now the next property, triangles formed by two tangents from outside the circle with the center are always congruent. For suppose this is a point P, we have made two tangents from P, that is T1 touching at A to the circle and tangent 2 touching at B to the circle. if we join center to the touching point of the tangents, we know that the distance is radius, and we know that these two distances are same because these two are radii. Now O to P line is basically the same side in both of the triangles. We know that this is a 90 degree and this is also a 90 degree. So therefore by 90 degree and these two sides and this angle will always be halved, and this angle will also be halved. So here if I join these 2 points A and B, will get some interesting results as well. If I say that this point is C, so this line is basically perpendicular to this line, and now this angle will always be equal to this angle. That is, I can say that angle OAC is congruent to angle OPA, and same for this triangle as well, that angle OBC will be equal to angle OPB. And similarly, if you calculate this angle, it will be equal to that angle. So this angle is POB, angle POA is basically equal to CAP, angle CAP, and just like that POB will be congruent to angle CBP. So these are basically can be proved by using simple triangle properties, that the sum of the angles is always 90 degree and nothing more than that. Now angles formed from the center to arc is always double to that from circumference, or vice versa will be angle from circumference to arc is always half of that from the center. For suppose this arc is AB, so if I calculate angle OAB, it is basically angle from the center to the arc. Now if we take this point PQR, so the angle formed on the same arc from the boundary, like angle P, angle Q, angle R, they will always be half of the angle from the center, or we can say in a manner as well that the angle formed by the center to the arc is always double the angle formed from the circumference, that is the boundary. Okay. Now cyclic quadrilateral, which is also known as the opposite segment property. For suppose we make a quadrilateral in a circle ABCD, angle formed by opposite vertices of a cyclic quadrilateral, angles formed by the opposite, these two angles, opposite vertices of a cyclic quadrilateral are always supplementary. That is, angle A, opposite angle will be angle C, the sum of these two angles will always be 180 degree, and the sum of these two angles will always be 180 degree. Also angles formed against opposite sides, basically this is the segment, and to that side angle D occurs, and to this side angle B occurs. So these two angles are on the opposite side of the segment, so we can sometimes say opposite sides or opposite segment, that is always supplementary. Now we have discussed a similar property before. So same segment property, angle formed by the same segment are always equal. Basically this is the segment, and this segment is opposite to angle X. For suppose this point is P, another point on the boundary is Q, another point on the boundary is R. So basically opposite to P, this is the segment, and opposite to Q, it is the same segment, opposite to R, it is basically the same segment. So angles formed against the same segment will always be equal. The angles should be from the circumference, that is boundary. Tangent angle with the chord is always equal to the angle opposite to that chord inside circle. For suppose this is a tangent touching the circle at point A, so basically this is the chord AC. AC is forming an angle with the tangent TA. So this chord has angle X with the tangent. So now the property is clarifying that angle opposite to that chord, this chord, will be X as well. So these two angles will always be equal. For suppose if this angle is Y, so now angle opposite to this chord will be Y as well. So you can clearly see that this angle can be found out by X plus Y and then subtracting from 180, and for this line as well this angle can be found out by X plus Y and then subtracting from 180. So I have tried my best so that students may understand the circle properties, and I wish that all of you have cleared your concepts. So keep remembering me in your prayers, and don't hesitate to ask me questions. You may find my number in the details, and you may comment as well, or any other problem. For next topic you may ask me what topic you want to study. Thank you so much. So nice of you. Allah Hafiz.